Hello, class. We just talked about different sources of indoor air quality pollution, things like dust and VOCs, etc. Now let's look at ways that we can mitigate some of that indoor air pollution that can build up. One of the biggest areas to look at is ventilation itself and being able to supply fresh air. Just as a refresher, we're going to talk a little bit about how ventilation works. If you recall, in a previous module, we looked at the difference between overhead overhead ventilation, which is what you see on the right-hand side, where air is supplied from an HVAC unit, versus underfloor air, which is on the left-hand side, and how we can use the natural buoyancy of air to reduce the amount of energy. And again, as a reminder, hot air rises and that we're really trying to bring air to the breathing zone where people are. So air and temperature. And again, as a reminder, we talked about raised floor, underfloor air distribution, also known as displacement ventilation. And if you recall from our previous lectures, we talked about how air can be provided at the plenum space, use less fans, and yet be able to have little controls in the floor so that you can control the amount of air that you're exposed to. We had also talked about radiant chilling and chilled beams, if you recall from our previous passive ventilation conversation a few modules ago. And with chilled beams, this is where you're allowing hot air to be sucked up into a chilled beam systems and let the air flow over radiant or chilled coils in which that air will drop. So now that was just a reminder of how ventilation works or can work from an alternative perspective, but let's also look at some of the sources. One of them is tobacco smoke. And there's a lot of ways that we can control the exposure to occupants. Number one is really not allowing smoking in a building. However, what you'll find is that sometimes people will smoke just outside of the front door. And unfortunately, when you open up your front door, then that smoke all gets into your building anyway. So, a lot of times LEED, for example, will suggest that you put designated smoking areas at least 25 feet away from any building opening. So that also means, not smoking on things like balconies. So not only moving designated smoking away from entrances and openings to the building, but really we want to also protect people from secondhand smoke. There's no use in locating a designated smoking section right next to an air intake that's supposed to pull air into your whole building. How many of you have lived in an apartment building and you can smell the person next door smoking? Part of that is because of the way that separation between units is designed. So, for example, you see the space above this little dash kind of line near the ceiling. That dashed line from there and above is normally referred to as a plenum space. Plenum space means like an open gridded ceiling where we can put wires for electricity, for lighting, for HVAC. That's kind of where a lot of the mechanical guts go. And sometimes those are open or have gaps between spaces. So in the middle example and in the And in the example on the right hand side, well, the one especially on the right hand side is a completely open plenum space, meaning that the ceiling, above the finished ceiling, there's an open gap between one space and another space, and that actually allows sound to travel. That also allows poor air quality to travel, and especially smoke. So a few ways to avoid that is having, like on the far left side, a full height wall going from the floor deck to the ceiling deck, so that there is no space for bad air quality or even noise quality to travel between spaces. And in the middle, it looks like there's actually a temporary barrier put between the two spaces to keep air smoke from mitigating from one space to another. So another way to help control things like smoke and even other areas where you may have poor indoor air quality, things like janitors' closets where we're storing a lot of cleaning chemicals, or even in restrooms where there may be sources of air pollution, is to create what's called negative pressure in that room. So, and you can do that with a simple just exhaust fan. So, for example, we're all pretty familiar with seeing exhaust fans in a bathroom, in a restroom. So, in that, the air is being sucked out. That creates negative air pressure in this room, meaning that when a door opens, let's say this is a restroom again, when the door opens, air is being pulled in to the space, not being pushed out. That'll keep fumes from the bathroom from emitting into the rest of the space. So similarly, we can create even indoor designated smoking rooms, for example, you'll find in some spaces, even though we really want to eliminate smoking in buildings altogether. But if you do have a designated indoor smoking area, you can create negative pressure to pull that out. We also find this happening in in a home, in a parking garage. Where we can have negative exhaust in that parking garage. So when you open the door from the parking garage to your house, you're not going to get toxic fumes coming into your house. We first talked about this ASHRAE standard, if you recall, when we were talking about energy. And if you recall, ASHRAE created a set of code guidelines that allowed different energy to be used, or energy recommendations for floors and walls and ceilings based on where you were regionally. Well, ASHRAE also helps set some guidelines for naturally ventilated spaces and mechanically ventilated spaces. Again, if you remember, ASHRAE stands for the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and they set a bunch of standards. And so a lot of the standards that they regulate are things like how much fresh air should be brought into a building at a base minimum. And sometimes they'll even vary that depending on the type of space it is. You may need more fresh air coming into a conference room because we have more people in the space than you will need in a single office. You may need more fresh air in a gymnasium where people are breathing heavily, versus in an office where people are sitting and kind of sedentary. So they'll actually determine a certain amount of air quality based on things like humidity, temperature, ventilation, the activity type, how many people are going to be in the space. And so they'll be able to give guidelines accordingly. The most common way that mechanical fresh air works, just so you know, is that, a lot of times we have these bulky units on top of a building. These are the HVAC, the HVAC units that pull. A lot of them are air mixing stations where air is being pulled into the unit, and then it's air filtered and air conditioned or air heated and then delivered to your space. And then also there are these major building exhaust vents. So this is where air is coming out of your building. So a lot of that is where, there is some sort of effective delivery for mixing of fresh air. And they normally come into the building and leave the building from units that look like this. Let's take a closer look at one of these units. So if you notice at the very top of the diagram, you see that little kind of slanted triangle. That's where the fresh air is coming in. It'll come into a mixing box, and that will become either, like we said, heated or cooled. And so that's fresh air. And then that will go into the building. And you can really determine the amount of fresh air that comes in. We talked about variable air volume systems when we first looked at natural ventilation about 5 different modules ago. But you can control some of these actually have controls that will help determine the amount of fresh air that needs to come into the space. And then we definitely want a place for that air to, a certain rate at which that air is also exhausted. So we're constantly being able to supply a certain amount of fresh air. But one thing to note is that the more fresh air that you have to bring into your space, and the faster that rate has to be turned over, it also means that that's a big energy suck. So because that means more air has to be brought in and conditioned. So there is an energy trade-off to supplying more fresh air, but there are ways that we can do it effectively. We had looked at this also during the previous one of our previous lectures, but CO2 sensors and demand control ventilation. Remember, CO2 sensors are something that sense the amount of people exhaling. We exhale CO2. We breathe in oxygen. So if we have a densely occupied space like a meeting room or a classroom or a theater where we have a lot of people exhaling at once, we can use something like a CO2 sensor that's on the wall of the room, and it'll sense that, oh wow, there's like the buildup of CO2 is pretty big in here, so we're going to bring in just enough fresh air to offset that to healthy levels again. Rather than just being able, supplying a constant amount, it's only doing it when needed. Same thing for a single occupancy office space. You may have one person in that room. You don't need the same amount of fresh air being delivered as you would in, say, a busy conference room. So this is where demand control ventilation can help. And in this, you've got louvers that are controlled in each one of those individual rooms. And so it will open and close accordingly. And let's not forget even just giving people access to fresh air. So even if it's not being delivered from a mechanical system, that, having the access to open up a window if your outside air is clean enough to be able to let that fresh air in. So a few other things we should keep in mind are some other sources of indoor air pollution. And a lot of times we'll find these in like janitor's closets. And that's because in a building, in a janitor's closet, you may be storing paint, you may be storing chemicals. There are cleaning products that may be off-gassing or that are being mixed. And so, having things like negative pressure and exhausting these rooms, or even using green cleaning products with low VOC emissions can help for that source. And strangely enough, a majority of the dust that comes into a building comes right at the bottom of your feet. So being able to have entryway systems also helps to be able to capture the dirt right off your feet. Now, LEED recommends that you have some sort of grills or grates or even mats that are at least 10 feet long in the direction of travel, so that a lot of the particulates that you would bring in off the street get pulled right off of your feet before you enter the building. Another strategy is filtering the air itself. So when we bring in fresh air from those units at the top of a building, you want to put in a filter to basically filter the air before it comes into all of the spaces into your into the building. So we normally have what's called HEPA or MERV, MERV air filters. MERV is a type of rating for the amount of thickness, for how thick and effective a filter can be. So the higher the MERV rating, the thicker the filter. But again, there's also an energy trade-off. If we're having to, that means that we have to push air through a thicker filter, which means you're going to have a little bit more resistance, which means that you need more powerful fans that can often require more energy to be used. So there can be an energy trade-off, just so you know. For LEED, we require or we recommend about a MERV 13 filter. So again, the higher the MERV rating, the thicker the filter. Here's another chart just showing some MERV ratings, how much dust and particulates it's allowed to pull out. There are some even higher tech options for filters. Some filters actually have a UV light that it's ultraviolet light that is able to kill a certain amount of microbes just by it passing through the light.